Were you scared? Don't worry, lightning is just an example of static electricity at work. In this video, we will tell you all you need to know about static electricity, as well as showing you how static electricity works in our everyday lives. Everything we see is made up of tiny little atoms. Everything from oven mitt's cousin to an apple.
All atoms contain protons, electrons, and neutrons. Protons have a positive charge, electrons have a negative charge, and neutrons have a neutral charge. Protons and neutrons reside in the nucleus of an atom. Electrons orbit the nucleus, therefore that's why electrons are transferred. Usually atoms have the same number of electrons and protons, which give them a neutral charge. When things rub together, electrons move. When atoms gain extra electrons, they have a negative charge. When they lose electrons, they have a positive charge. When charges are separated like this, it is called static electricity.
There's one law in static electricity that you must know about. It is Coulomb's law. This is the force or repulsion acting along a straight line between two electrical charges. It is directly proportional to the product of the charges and inversely to the square of the distance between them.
Here is Coulomb's law. F is electric force, K is Coulomb's law constant, Q1 is quantity of charge number 1, Q2 is quantity of charge number 2, D is for distance squared.
And here is an application of Coulomb's law.
Given Q1 is 1 coulomb, Q2 is 1 coulomb, D distance is 1 meters, K is 9 times 10 to the 9th newtons times meter squared over coulomb squared, and find F, and plug and chug. And force is 9 times 10 to the 9th newtons.
When two objects have separate charges, if they are opposite, they will attract each other. And if they are the same, they will repel each other.
It is easy for electrons to move through conductors. It is not easy for electrons to move through insulators. Insulation from your house is different from what we were talking about. This is an example of a conductor. This is an example of an insulator. Here are some experiments you can do with static electricity. Here we have an electroscope. Electroscope is a device which is used to detect a presence of a net charge. This is made up of a glass jar, a plastic lid for an insulator. This will hold the metal paper clip, which is a conductor. At the bottom of the paper clip, there is 2 sheets of aluminum foil hanging on the paper clip. The aluminum foil are also conductors.
First, rub the balloon on the wool so electrons are transferred from the wool to the balloon, giving the balloon a negative net charge. Observe as the aluminum foils repel each other. When Albert brings the balloon toward the top of the paper clip, the negative charges in the balloon will move down the aluminum foils. Because like charges repel each other, the aluminum foils will repel each other. This will also work with 2 positively charged items.
So why does your hair fly up off your head when you take your hat off? As the hair and the hat rub together, electrons move from your hair to the hat, giving your hair equally positive charges in each hair. Since they have nowhere else to go, the hairs rise up off your head as they repel each other. Here's another experiment that can be done with a balloon, a piece of wool, and hair. First, rub the balloon against the wool so that electrons are transferred from the wool to the balloon, creating a negative charge in the balloon. You can create this charge even by rubbing against hair. Then watch as the electrons are transferred from the hair to the balloon, and the hair is attracted to the balloon.
When you walk across a rug or carpet, electrons move from the carpet to you, giving you extra electrons. Then when you touch a friend, it will send an electric shock, transferring the electrons from me to him.
Cut!
This is the dancing cereal experiment that you can do with a balloon, Rice Krispies cereal, and a piece of wool. First, you rub the balloon against a piece of wool, and the wool is transferring electrons, giving the balloon a net negative charge. When you put the balloon over a net neutral charge of the cereal dances up to the balloon.
Rubbing a plastic comb against wool creates a new attractive force between the plastic comb and these bits of paper. This causes the bits of paper to accelerate upward against the force of gravity.
Here's another example of electricity at work. Here's an experiment you can do in your very own home with just a comb, a faucet, and hair. Make sure you wash the comb before you do this experiment really well so it will remove any oils on the comb.
And make sure you dry it well so the water won't alter the electrical charge.
First, turn on a very thin stream of water in your faucet. Next, to create a charge in the comb, brush through your hair with it several times.
When you comb your hair, electrons are transferred from your hair to the comb, giving the comb a net negative charge. When you hold the comb up to the polar water molecules, the positive parts face the comb and the negative parts face away and repel each other, so the water bends.
It's time to play
Will It
Conduct!
For this week's episode of Will It Conduct, we have plucked a random freshman from the very halls of Park Hill High School and asked him to say whether or not he thinks each of these 8 items will conduct. If he gets 5 or more right, then he will receive the grand prize.
And the grand prize is a one-of-a-kind tinfoil hat, only sold in Sweden. But there's a surprise. If he gets all 8 correct, he will win a 2005 Volkswagen Golf. Sarah loves it. Do you? I'm Brian, your host of Will It Conduct. Here is my co-host and technical advisor, Sarah. She will explain to you how we're going to play Will It Conduct.
Here we have a circuit made from a 9-volt battery with wires attached to a light bulb. And we will put the conductor/insulator in between the end of the light bulb and the wire. And if it conducts, the light bulb will come on. And if it's an insulator, the light bulb will not come on.
I am here with our contestant today from Kansas City, Missouri. What is your name?
David Elwood.
What class are you in?
I'm a freshman.
And what is your GPA?
4.0.
Ooh, smart one here. And what is your favorite class in school? Physics! Ooh, will he be able to take the ultimate challenge and get all 8 right? Stay tuned. You ready to play? Our first item today is a ball of aluminum foil. David, will it conduct?
I'm thinking. Yes, Brian. It will conduct.
What does the audience think about this?
Let's test it. It conducts. Yeah! David, you're off to a good start. On to item number 2, which is a balloon. David, will it conduct?
I think. No, it won't.
What does the audience think about this?
Let's test it. No, it does not conduct.